Hello again, everyone, and welcome back to our OpenDev virtual event number 2. I am Jonathan Bryce, and Ashley Ferguson and I will be hosting again today. And this is our event that's all about hardware automation. So we've got 2 more days of discussions around automating all of the hardware, all of the gear that's in our data centers. And that'll finish up our second event in our OpenDev series. We also have a couple of more events coming up. Ashley, if you want to talk about what's up next.
Sure, yeah, so our third virtual OpenDev event, the last in this series of 3, will be all about containers in production. So if you're interested at all in containers, make sure to check that event out. It'll be August 10th through 12th, same exact time as this one, 3 hours a day for 3 days. So make sure to go register for that now. And then I'll let Jonathan talk about our summit later this year.
Yes, we have just announced that our Open Infrastructure Summit in October will be going virtual as well. I'm sure that we are all dying for more virtual events. So now we have the opportunity to join together again through the magic of video conferencing in October. This event will be more traditional presentations and some panel discussions, and kind of bringing our summit format to the virtual event space. There's a CFP open now, cfp.openstack.org, if you would like to present or speak or propose any topics there. So go check that out. That's open for a couple of more weeks. And mark your calendars for October 19th to the 23rd for the event itself. So before we get started today, I just wanted to do a quick recap of the event from yesterday. So as those of you who have participated before know, we do a lot of note-taking in a shared tool called Etherpad. And yesterday was no different. We used this Etherpad. We'll have one that's available for today as well. A couple things to note. You'll notice that some of the names in the Etherpad attendee and participant list have an asterisk beside them. If you, when you go to the Etherpad today, if you put your name in and you put an asterisk, then that's an indication that you're happy to speak up and join the conversation, and the moderators will know that they can call on you or invite you in to share your thoughts. The topics that we covered yesterday were quite broad. It was everything from the basic bootstrapping of hardware all the way to managing firmware and BIOS and trusted computing settings and hardware verification and all kinds of things related to that, security and more. So a great discussion. And there were a couple of items that stood out as areas for potential collaboration after this week. Some documentation around standard operating procedures for managing keys, creating a matrix of kind of the specifics around firmware per vendor and platform that could be useful for people who are managing mixed environments or evaluating different types of hardware. And then there was a lot of really interesting discussion, I thought, around kind of managing the load in the data center from a power and cooling standpoint, and how to associate workloads and hardware operations when you've got a big fleet inside of, I think James said that he runs his servers in a barn. So wherever your servers are, whether they're in a barn or a data center, you know, if you've got a lot of them, thinking kind of in a systems mindset around that was one of the topics that I thought was pretty interesting yesterday. So a lot of interesting discussion yesterday, and we have more ahead of us today. So Ashley, if you want to talk a little bit about the format and get everybody up to speed on how to participate.
Yeah, absolutely. Thanks, Jonathan. Yeah, so welcome back. If this is your first day of OpenDev hardware automation, welcome. If you were here yesterday, then you've probably gotten the drill down by now, but just wanted to cover a couple things to help this run smoothly. So obviously our main tool that we're using is Zoom. That's what we'll be using most of the time. And then the other thing we'll be using is an Etherpad, which Jonathan was just showing you. So most of you are familiar with that. But the Zoom chat will be primarily used for technical questions, things that are relevant to the topic, conversations and discussions. We use that to flag topics to the moderator, or if you want to jump into the conversation, feel free to throw it in there so that we can get to as many of those questions as possible. But obviously we want to hear your voice and hear from you and your experience. So feel free to unmute yourself and jump into the conversation at any time during the discussions. Feel free to raise your hand if that's something you want to do and jump into, and we'll make sure to try to get to everybody. But if you're not talking, please make sure to keep yourself on mute just so that we can avoid any background noise or distractions, because virtual events are hard and we're all still getting used to them. And then Etherpads, like Jonathan said, this is a place for notes, feedback. It's kind of where we've collected all of the information that we discussed in the topic discussions, and it will live on for a long time. And like he also mentioned, feel free to drop your contact information in there if you're interested in connecting with people after the event, and then go ahead and put an asterisk next to your name if you're interested in talking. That way our moderators can easily say, hey, it looks like you're interested in jumping into the conversation, and give you an opportunity to speak. And then if you need help at any point during the event, feel free to email events@openstack.org. We'll be on the other end of that, ready to help you with any login technical questions. If you're having trouble logging into Zoom or anything like that. And then the Zoom chat, like I mentioned, will be used for topic discussion content. So let's keep that there. And any other logistical questions, feel free to email events@openstack.org. And then there's also a tips and tricks Etherpad that was emailed out earlier that we'll also drop in the chat right now. So feel free to check that out if you have any other questions. And then just as a friendly reminder, this is an OpenStack Foundation event. So we do abide by the OpenStack Foundation Community Code of Conduct. So just as a reminder, please be courteous, conduct yourself professionally, and please respect each other. And if you need to report any violations of that, you can visit openstack.org/code of conduct, which is at the bottom there, and that'll have instructions on how to do that. And now I'll turn it back over to Jonathan.
So just a couple of thanks before we get started with the day. First of all, thank you to our programming committee, Mark, Keith, James, Julia, and Mohammed. They are responsible for kind of outlining the content and the flow. And they also helped us to recruit some of the people who are speaking and sharing their experience here. So thank you very much to the work of the programming committee. And also I want to thank the Platinum and Gold members of the OpenStack Foundation. They are the sponsors who enable us to do these events and organize these opportunities for the community to get together. So thank you also to all of these companies who support the work. So today we are going to have two sections with a short break in between, and this is going to be talking all about kind of consuming bare metal in different ways. And the first part will be dealing with hyperconverged and auto-scaled workloads, and the second part will be talking about preemptible bare metal as well as Redfish for hardware management. I think that was a topic that that when we had our survey and asked people what they were interested in, Redfish came out as a popular topic. So good to see that that's a topic of interest and one we'll be getting to today. And after that, we have we'll come back to Mauro, and we'll talk about networking and networking security and managing networking in large-scale environments. And then we'll do a wrap-up for the week to see what next steps there might be that we should continue working on in various projects, or potentially documentation, like I mentioned earlier, or white papers, or anything that could just be useful to get out there in the open. So 2 more days left with some great topics. Let's go ahead and get the discussion started. So to take the first section this morning, I will pass it once again to Mohammed Nazer, and he's going to handle part 1 of consuming bare metal.
Thanks, Jonathan. Good morning, again, everyone. Or I guess in some parts of the world also good evening. And I don't want to say good night. I'd say that's it's pretty late to say that. First of all, yeah, we have an Etherpad going just like we had yesterday. So I'd like to invite everybody who'd like to be part of taking notes to open that up and throw your name in there if you're participating. It's really helpful to know who will be there, and make sure to leave an asterisk if you're looking to participate. Our first topic that we came up with today is hyperconverged. And I guess one of the nice questions that was added this morning was really, what do we define hyperconverged as? I think there's different various definitions of what hyperconverged is. And inside our realm of the industry, hyperconverged implies that you have storage and compute resources on the same machines. That's what I think when I think hyperconverged, but I'd be happy to hear on some other ideas of what other users consider hyperconverged to be.
I kind of view it as both storage and compute and all of your networking in kind of like a little isolated island that can operate as highly efficiently as possible. Is that a word? But I feel like when I put the question on the Etherpad, I was like, well, let's make sure people are using the same words. So it's really important, I think, for people to kind of convey what they think, even if it's just agreement.
Yeah. So it's really interesting. We have a comment from James in the chat saying that for them, it includes controller as well. And for us, it doesn't, for example. So are there any other users that also feel like it includes controller in that equation?
Yeah, this Beth, let me also bark in. I think hyperconverged came out of the grid computing community. So a lot of the terminology and what it encompasses comes out of that thinking. So in that case, it's kind of a all-encompass. It has everything in it, which it does include the controllers.
Mm-hmm. That's interesting. So then on that note, I've found it pretty difficult to already get storage and compute interacting without intervening too much with each other. Has anyone kind of added the control plane to the equation, and how do you make sure that things don't start, slowing down each other, or specific services start eating up a lot of resources?
And are there specific architectural decisions, or is there software settings, or is it application layout?
Yeah. I noticed some of the people in the chat are talking about their use cases. I'd be really happy to hear you, maybe if it's possible to get on voice and talk a little bit about the use case, especially I think Jaden's talking about carefully tune and reserve memory and resource allocations. That's really interesting.
Hi, so this is Jaden. So we're using OpenStack and Ceph for cloud and for compute and storage. And so OpenStack, we use the compute settings for reserving resources for the operating system. And Ceph has similar settings too, where you can reserve fixed amounts of CPU, threads, and RAM for other uses. So that's what we do to achieve this kind of super converged infrastructure where we can run the control services and the compute and the storage all on the same hardware, with the understanding that this is a small scale kind of, maybe you wouldn't want to run like your big operation on this kind of setup. This is more for like a development kind of cluster, or a testing kind of cluster, or a small scale production cluster.
So that's interesting, because that really wanders into the edge use case, which is what the comment I put in to the Etherpad. Because if you think about edge is a form of hyperconverged, right? Because if it's, if it's one rack or a single box, it still has to have everything incorporated in it. But I don't consider edge particularly to be hyperconverged. Or maybe that's just my thinking.
I can maybe like contribute our use cases as well. So this is Arne from CERN. We have like basically like two use cases that we would call hyperconverged. So at CERN we run our own like massive storage system that was developed in-house. It's like 250 petabytes raw capacity. It's thousands of servers. However, the servers that we buy are usually not bought specifically for the storage system, at least the head nodes. They're usually bought for the batch use case. But then all the CPU and all the RAM, so we basically buy the same hardware for all use cases, more or less, to not have like too many different. So one idea that we had years ago was to like make use of these CPUs that are on the storage servers. So we put some of our batch capacity there, and then this went into containers to basically seal it off from not disturb the storage system. So this is basically, so one use case is to basically make use or efficient use of the resources that we have and use every cycle that we have. So that's one use case. The other use case we have is like similar to what Jane just described, which is a cell in OpenStack where we combine Ceph and use the storage that's on the hypervisors in order to have a Ceph cluster or serverless cluster in the same cell. And the use case here is not so much, it's also like efficient use case, but efficient use of the resources, but here it's more to achieve low latency. So this is specifically for VMs that then run the cell that need low latency access to the data. So we have one setup for HPC, for instance, and for some other application like Kafka queues, which need to for instance, have very quick access to the storage. So this is kind of the two use cases that we have. So it's like efficient use of resources or like putting everything closely together to reduce latency.
So I think just an interesting question that I want to throw back at Jaden, and I don't know if maybe this is something that makes sense for you or not, but one of the things that I've seen in hyperconverged deployments is it's hard to grow, while it starts easy in theory to grow one aspect like storage or compute, eventually you reach a point where it doesn't make sense to linearly continue to grow storage only. Sorry, both storage and compute every time you add a new node to that hyperconverged cluster. And so if you start adding storage, you start eating up into the memory that was previously allocated for computes, and you kind of have this weird off balance. Have you kind of thought about something like that, or have your setups mostly been a single node thing?
So we start with a 3-node setup, and for our, when we want to scale, we just add additional hardware units. So we use small hardware units for our, for these little clouds. Like we'll start with 3 that are running in a control plane compute and storage setup. And then as we want to scale those and scale CPU or storage resources, we'll add additional hardware nodes that are configured to provide either just dedicated CPU or dedicated storage. One of the things that helps us is that these clouds are small enough that the control plane services don't get too taxed. I think it's something that Slavash in the chat box mentioned, is that because I know for a big cloud, you're going to run a lot of resource usage on your control plane, and it's going to be busy and really active. But since these are relatively small clouds, they're only going to run at most a couple hundred VMs. That it's not too bad. But again, like we understand that this isn't, you wouldn't want to run your big Hadoop cluster or some kind of big data crunching or processing kind of use case on this. You'd want to get something more powerful, or something with more of a dedicated control plane or something like that. But that's how we scale, is that we just add additional hardware units that either provide compute and storage, or just compute or just storage, and attach them to the existing Ceph cluster or the existing OpenStack cluster.
But then operationally, do you kind of have issues with like this quote unquote unicorn compute nodes that are like not really a compute node, have other things? We have different profiles of systems.
We We haven't run into too many problems with that yet, but that's something that we'll have to run into. So you mean like when you're allocating VMs?
Well, like let's just say you want to run a maintenance, and you're like, okay, well, if I do a maintenance on these subset of machines, that's a lot more straightforward than this other subset of machine, because this one only has VMs, and that's easy to deal with. But this one also has the control plane running on it.
Oh yes, I understand what you're saying. I will say haven't been running these kinds of clouds in operation too long yet. So that's something that we'll have to address. I think I know we've been trying to plan for like updates and those kinds of things. We use Kala and Kala Ansible, and that's been those projects have been helpful. They use containerized Docker container, like they use Docker containers and containerized OpenStack services to make it easier to do deployments and upgrades. And in our experience in running a larger cluster using those things, it's been fine so far. But I think what we're planning on doing, I don't know. We don't actually have I don't think we have a plan for that yet, because it's not a problem that we've quite gotten to.
This is what we're here to discuss and learn.
Yes, I mean one of the things that we have on our roadmap is like, what do we do from when we have a release for OpenStack that we have to do, and we have to do like a jump from Train to Usuri or something like that, or Usuri to Victoria. Like, well, how are we going to manage that, especially if we have multiple, if we've got 10 or 20 of these little clouds set up, how are we going to manage that and coordinate that?
Jaden, that's actually a very tough question, and unfortunately, there are companies that have gotten stuck at various points for exactly that reason. So yeah.
I'm sorry, you can finish.
Okay, I was just going to say, you have to really think about if you have the capacity to do like a rolling upgrade.
Yeah, I would say I think we so in our upgrade process experience with Kala, rolling upgrades seem like it's been pretty good, and then you can do upgrades of a lot of control plane services and core services without disrupting your virtual machines. That's fortunately, I think, a testament to how well OpenStack has things orchestrated in that regard. I will say one of the advantages to our small cloud strategy is that a user could just make we could just make another small cloud and mirror over the data onto the new release and test it out and have it be ready to go and validated. And then we just discard the old cloud or recycle the hardware and update it after it's no longer in use. That we have the advantage of not having like, 1,000 node deployment or some huge deployment that we have to worry about managing. That we can just make a new small cloud and migrate to that to move forward.
So I can chime in here as well. This is James. Jaden's setup seems extremely similar to mine, actually. And I don't know if you work for a university or not, but I do, and maybe that's why. So we have primarily a lot of older equipment, 11th generation Dells, and we've got about 6 racks of servers, but each rack is its own deployment. So we have maybe anywhere between 10 to 15 servers doing its own thing. So we also use Cola, OpenStack Cola, for Dockerized containers. And we do hyperconverged. When we bring down a control node, because we do HA, we're very careful, but it doesn't seem to impact anything because you've got the other 2 controllers, going. And we do an A/B system where, we'll have one. We don't do we theoretically could, I suppose, do the rolling upgrades, but we prefer fresh installs. We fine tune it every time we do a fresh install. So that's been our procedure.
Cool. I'm glad to hear that, James, because I think that's what we're looking forward to when it comes time to do like the big releases or big updates, is that we'll just try to steer our teams and consumers of our clouds to just getting a new cloud and mirroring the Ceph data over, doing their tests and validation checks so they can have that change without having any kind of disruptions to their regular operations.
Yeah. And we've had some issues with and perhaps it was user, essentially my error because I'm the one who deploys the clouds. I've developed a series of tests just to smoke test our deployments as well. We use Ceph, but once Cola removed Ceph from their deployments, we stopped. Primarily because it's me who's deploying everything, and so I haven't devoted enough time to master Ceph plus OpenStack plus all the other stuff that I'm supposed to do, because that's not my primary. This isn't even my primary job. But I'm going back to yesterday's conversation and today's. I'm very excited to see how much Ironic has changed, because right now we use Mass, and I'm hoping that we can switch it over to have sort of a triple O type setup where we could have a small cloud but deploy everything else onto the other systems instead of using Mass, and that would give us our Windows systems that we need as well. So it's nice. It's nice seeing this progress.
Yeah, I will say we use Bifrost, which is standalone Ironic. We've been using that, testing that for deployments. And I see John Garbett asking about KOB. We tried KOB, but for our particular use case, it was a little too opinionated. I will say KOB, though, probably is a good fit for folks who want to do something like triple O, but maybe they want to have it be a little lighter, because we tried triple O out as well, but found it was a little too, well, it was even more opinionated than KOB was. That it had a lot going on. We didn't want to have to run an entire OpenStack cluster to deploy other OpenStacks, and KOB seemed like it was a good fit for that. So I would certainly encourage people to look at KOB as well.
Maybe that's
you, James.
Maybe that's what we need to look at too. But it'd be good to connect with you outside of this as well.
Oh yeah, I would love that. I think we've got a lot of. It sounds like we could share a lot of expertise and experience.
Yeah,
in this
definitely,
area.
definitely.
So the natural question might be: is there something that could be done with the bare metal SIG to help raise some of these use cases and configuration possibilities to the public?
I know for us, we tried using Ironic several times in the past, but we've at least for us, and it might be that, like I said, the age of our equipment, but it was always rather difficult to get set up, and we'd spend days or weeks trying to get it up and running, and we just weren't able to. So we reallocate the servers so we could use them for other things. So I think always the making it as simple as possible is always a good thing. But besides that,
I'll say for our part, we're using Bifrost, but we actually started with KOB, and that KOB is really good about getting Ironic Bifrost set up for you with some good sane defaults. It gives you the tools you need to get started doing your work with your hardware. I'll say, like I said, for our individual use case, we're kind of pulling back from KOB now that we know more about how Bifrost works and how KOB works, because it's not exactly a good fit for our use case. But for us, it's certainly helped us get to the point where we can say, yes, we know how to use Ironic. We're comfortable to try to do it on our own. We're still not there yet. We're still using the KOB seed host, even though we're not using like the KOB command line stuff so much now for our usage. But I can definitely say it was great for us to go through that experience using KOB to learn the basics of hardware management and that kind of stuff. And
I know yesterday there was some conversations about how you monitor the hardware. We grew an in-house tool that probes all the IPMI diagnostics and reports back to us on a website. So we have it display essentially our racks in physical form with the U dimensions and everything like this. And if it's green, everything's running nicely. And if it's not green, it'll be red, and it'll show us the errors as well that are happening there. So we can see you know, a RAM stick died, or a CPU's failing, or a hard drive is failing, or a hard drive failed and came back, you know, these type of weird things. And then if there's a communication error, it goes orange. So, you know, that's what how we monitor our hardware remotely.
I guess James has managed to eliminate the idea of walking through data centers by replacing it with a website that you look at instead.
Yes, yes, absolutely. So my role is to help with research. My secondary role is to do IT, and so I can't spend my full job doing IT if I've got to help with research. So I've needed to automate as much as we physically can, which is why Mass, Ironic, these type of things would be, you know, great to have working. And, you know, I've been using OpenStack for a long time, but yeah, Ironic has just been that one that I've had issues with. So, you know, we try to eliminate walking across campus as much as possible.
Yeah.
Well, if there's any
issues with Ironic. I'm sorry.
You can go ahead.
So I was just asking what your biggest hurdles were with Ironic when you were attempting to use it.
For us, I think it's our network setup that's the issue. If I'm remembering correctly, we to Pixie, and we had similar issues so we were able to Pixie it, but we weren't able to get the rest of the networking up because of how we had our setup. So we had one NIC that is air gapped, which is what we're using to Pixie it. And then our public network is another NIC that could get onto the internet and do other stuff. And I think that was our I think that was our biggest issue. It's been a long time though, so I may be missing some things.
We might have had some features recently in the past year that might help those sorts of environments, like multicast DNS and auto discovery of components running. So that might be things that help those environments. But I think if we can go back to one of the questions that was asked in chat, I think it'd probably be pretty good for us to highlight that.
Yeah. Just going back briefly to a question that was asked in chat earlier, which is asking if the meaning of hyperconverged means 3 controllers that are also compute, or spreading the services all across the compute and storage nodes. And I think this might have different answers depending on the scope. I know Jaden, maybe you can share a little bit about your answer here. And
Sure. So for, like I said, for my part, for our deployments, so we can have high availability, we run on each individual node, we run compute. So OpenStack Nova, we run Ceph, and we run all of the control plane services. So Neutron, Glance, Placement, Keystone, all of those different services. And we run an instance on each of the 3 nodes so that we can enjoy that high availability, so that if we do lose one node, like James said, that we can still be up, we can still have our VMs work properly and not have any disruptions for our tenant users, even though maybe they can't create new VMs or manage that way. But I mean, I hope if we have a published maintenance window and people understand the expectations, they'll know, hey, your websites are up, your applications are going to keep running, your work's going to keep happening, just don't do anything right now. Take a break, and they'll be okay.
I'd love to also hear Beth's POV from like an edge perspective. Is that the same definition, or?
Yeah, I've been thinking about this because edge is, edge has the additional constraint of the edge is far away, right? And not necessarily, you risk, it has to stand alone, right? So by its very nature, it has to be hyperconverged. So I think that, and again, I think the hyperconverged question kind of bifurcates at this point, that edge is a flavor of hyperconverged, but I think since hyperconverged came out of the grid architecture model, we tend to think of it as massive. But edge is, of course, not massive by its very nature. So I guess I'm blabbing here. Hopefully you got figured out what I just said.
So I guess it feels to me like while we're talking about hyperconverged and like constrained environments, I guess in an edge scenario, it's not necessarily, we're talking about a constraint of one rack, and that's probably like that's a small constraint in the context of an edge deployment, but it's probably a larger one for someone who's trying to have a small deployment for their, you know, their small business or something like that.
Well, one rack is I mean, for many edge, that's big.
Oh, okay.
Yeah, I mean, the telco edge tends to be in a, you know, a small number of racks. But in my world, edge is 1 or 2 boxes. And there's a lot of scenarios out there where where people are looking for 1 or 2 boxes. I mean, a retail environment, for example, they want to minimize the footprint down to as little as possible.
This is Jane again. I used to work in hospitality, and I know it's funny to think of this as edge computing, but I guess it is. We had one server behind the front office that like powered the local property management system, and it synced to the central database. And that was kind of a big thing like that. I think you're right that businesses really just want 1 or 2. They're going to have the minimum amount because they just don't know, like, it's just, they don't understand the technology, or they just want it to work.
Well, and they don't have anybody on site. I mean, retailers in particular, you know, think the coffee shops of the world, you know, they have a bunch of stuff that needs to be out there at the edge. They can't all run it over the cloud. And retailers are particularly sensitive to, you know, if it's all in the cloud and they lose the ability to do credit card transactions or, you know, take sales, that can be really expensive.
At the same time, it seems like they have, if they're only deploying 1, maybe at most 2 machines, it seems like that they either have built the processes and supply chain to be able to recover quickly regardless, or they just don't see the cost benefit hashing out to be 3 machines or 2 machines sometimes.
You know, retail runs on a really thin margin, and yeah, 2 or 3 machines for many of them is, they have to think about it. I'm working with one retailer. It's in the Quickie Mart business, which is, you know, the you know, if you go into a gas station, there's that little market there. Think about those, you know, they run on razor thin margins. They don't have room literally to put a rack of equipment.
Yeah, that's really interesting, actually. So that's kind
I'll
of
say for hotels too, it's the same kind of way, that there's
Same,
just
yeah.
too tight on the margins, and the I would say the leaders don't understand the technology to really well enough to be able to understand the business value, for someone to articulate the business value to them.
Right. And if they need to have somebody on site to babysit that rack, that ain't gonna happen.
Yeah. So I think that brings another interesting point, which is when we're talking about kind of hyper-converged systems, I guess there's like 2 stages, right? Because we have hyper-converged that, you know, I have the comfort of a rack and cooling and whatnot. I just have to have a small footprint. And then we have another use case of hyper-converged, but I also probably need somewhat of a resource-constrained server that is not overly expensive, with kind of more cheaper hardware to make it sustainable, because, you know, that small Quickie Mart you talked about is not going to spend $15,000 on a full system unit with fans and everything running.
Yeah, that's where we are. That's where our hyperconverged use case comes in, is that we are targeting, it's a super microblade sled that has 2 server nodes for a single hardware sled. So it's like a hyperdense, low cost kind of cloud hardware that we're using. So you have to do, if you want to run the whole cloud on three of these guys, you have to really be tightly constrained on your resource usage and how much you're giving everybody. You have to be real strict with it. And it's so that we can have low cost cloud. So we aren't having to spend $15,000 or $20,000 just to get a cloud for somebody to use to run like a little CI/CD workload or something like that.
Well, let me add to that, which is, again, going back to this quickie bar company, because I kind of pushed back at them and said, well, why don't, are you looking at the Nutanix box, or, there's a couple other boxes out there that are hyper-converged. And, they basically said they're too expensive.
Yeah. Yeah, that's kind of an interesting approach. So I see some discussion going on right now that started by John talking about using hyperconverged disks instead of Ceph. John, do you want to talk a little bit about that point? Maybe we can discuss that a little further, because I feel like it's an interesting discussion to have.
I can do. I guess I'm still struggling with the concept of hyperconverged a bit. Well, the definition of it, I think, is a good question. So I guess I was thinking about, if you have a hypervisor or whatever, and it's just using the local disk, does that make it a hyperconverged workload? It's kind of, in that case, you've sort of almost got no virtual storage. I suppose you've still got QCOW in the way. But,
yeah.
And sort of following on from that, I guess I was sort of saying, I was backing up the support for the KOB model, where you're kind of using Ironic to install the hypervisor. Because in a sense, I think we've been using a lot of Ironic to install storage workloads in general, whether they're like shared file systems like Lustre or BGFS or Ceph or the hypervisor itself, I guess. They're kind of in a similar frame.
Yeah.
I was just wondering if people have seen the same thing.
Yeah. I think it's an interesting question with regards to if the storage is in the same node, if that's actually hyperconverged or not. I don't know. I think when we're thinking yeah, of course, but it is storage and compute on the same machine. Is that hyperconverged?
Yeah, it says it's not off box, is it? It's not a SCSI card to some JBOD at the bottom of the rack. But
yeah, so that's an interesting question, and I don't know. I guess to me, it's always been on a lower layer of like, or is the infrastructure services, is Rabbit and is Rabbit and the Nova services and Neutron and all that stuff, is that all running on in the same machine in the same box, kind of like an all-in-one? That's hyper-converged. Whereas, like, for example, I would take the case of CERN, where they use local storage on their hypervisors, and I don't think CERN is using a hyper-converged setup. Well, at least that in my terminology, I don't think so, at least. Cool, that's really interesting. Yeah, I think it's been a pretty interesting discussion that we just had on hyperconverged. I don't know if anyone has kind of any comments to also add on any of the points that we have put on, because we also talked a little bit about, it seems like there's some comments also about hyperconverged Ceph things as well. I don't know if anyone has actually gone that far from the million warnings that are on the Ceph documentation saying not to do that. I was just wondering if someone has actually went ahead and did that, and how they are doing that.
I mean, that's what we do. We run the Ceph OSDs on top of the same hardware with the Nova hypervisor and Neutron and Rabbit and all those kinds of things.
So your Ceph monitor and Ceph OSDs are running on the same nodes?
Yes.
I see.
Yeah, we have a 4-node deployment with Ceph, where that's our 3 controllers, our 4 computes, and our 4 storage. So all on 4 nodes. So yeah, it runs. We remind that one has not a whole lot of storage. I think it barely has 1 terabyte of storage between the 4 nodes. So we just remind our users that, go easy on it. But we have another, talking about hyperconverged without Ceph, we have another actually smaller 4-node deployment. We removed the Ceph because the users were complaining about how slow it was taking to boot up some VMs. And so we did it on disk, and they're able to get their VMs up a lot faster. But it's again 4-node with 3 controllers. So those are our 2 smallest clusters that we have. The others are usually triple that size or so.
Yeah, I mean, like I said, for the key for us is that we do tell our user and expect our users, hey, this isn't a thing you want to go crazy on. This is the little cloud you use to learn the basics of OpenStack and how to do cloud native application development and processes. And then when you get ready to go big time and do production stuff, let's add some more nodes, or let's get you on this other hardware that'll better suit your needs. That this is just so you can really get into the ecosystem at a cheap price point and accessible way for us.
Mm-hmm.
But like, can I get back to? Sorry.
Yeah, go ahead.
So in our case, just to be clear, and like in the Sun's case, it's really like we have a set of hypervisors, several 10 of hypervisors, and they run Ceph on the very same node. So it's like they are basically running Nova and Ceph on the same nodes, accessing the local drives for I/O, and then we have VMs hosted on these hypervisors. So it's all in this set of machines for the low latency access. So, and then we make sure that like, okay, it took us some time to figure out how to like protect services from each other, so that if you like put on VMs, they don't like affect the Ceph service, because then they could be booted, for instance, from volumes that are on the same in the same cell, right?
Yeah. So I'm curious then, for those that are running both the Ceph monitor and the Ceph OSDs on the same node, how have you dealt with upgrades, or is that something that you haven't gotten around yet? Because usually there's some recommendations around the order of upgrading, and if everything is all running on the same host and you upgrade the packages, it's very likely that you might end up in a situation where some of the packages get updated. Like you have some OSDs that are running newer versions, but the others are still running, or the other monitors are still not running a newer version. So has anyone kind of explored that idea?
For our part, we use containerized Ceph. We use Ceph Ansible to deploy our Ceph. We're going to probably switch to Ceph ADM in the new version Octopus. And Ceph ADM uses containers by default for deployment. So I know that would help protect you from updating like operating system packages underneath Ceph. And with the containers, you can just do it the way they recommend it, because the containers, as far as they know, they're separate hosts effectively.
Mm-hmm. James, have you, or sure, you can go ahead, Arnie.
So one of the things that we do is like we have like the mons in our case are VMs, right? They're not physical nodes. So this way we can also like in that cell, we can move the mons around when we do upgrades, for instance, and then have like go in stages when we upgrade. For instance, when we have to do a reboot, some of the OSDs will go away, but Ceph doesn't care too much if it's not too many. And then mons we kind of basically can shuffle around in the cell, for instance, when we need to do upgrades.
Mm-hmm. And James, have you gotten around looking at that issue, or is not something you've gotten around yet?
Yeah, for us, we haven't really done that because we usually do clean installs. So we haven't had to do any updates. I know what the last gentleman said about using VMs for the Ceph mons. We looked into that. We had a lot of performance issues with that. Surprised you're not running into that as well.
Mm-hmm. Yeah.
Well, what we do. So one of the reasons, or one of the things that we do in order to protect the services, I mean, as I said in the very beginning, when you have to, or when you run multiple services on the same host, you have to make sure that they don't like cross-talk somehow. So one of the things we do this for the first use case is like to have this batch computing in containers and C groups set up so they don't like exceed the amount of resources that they're allocated. And for VMs, for instance, we use pinning so that they have like CPUs that belong to a specific application so they don't interact either. So, but most of our like infrastructure in Ceph, and we have like, I don't know how many Ceph clusters we have, around 10 or so. Most of this run with like virtual machines on the control plane.
I kind of think it's also important to take a step back when we start talking about services colliding, because I/O patterns with disk controllers or storage controllers you can have very different behaviors of those devices based on the pattern size of operations that you're doing against them. So one person's load may look completely different from another person's load, and the disk may behave completely differently.
Mm-hmm.
Yeah, I'll second that. I know our load is small because we're an institute. We have, I don't know, maybe 20 people on it. 100, maybe 100 to 200 VMs depending on what we're doing. But it's that's spread across maybe 15 servers or so. So it's none of our servers are ever heavily taxed. There's always tons of compute available for everything, and some of our newer servers have SSDs, but even the majority of ours just have spinning Rust. So yeah, low load usage.
Does anybody use a dashboard with HCI? Ceph dashboard?
We have the Ceph dashboard.
We use a Prometheus exporter that is now native to Ceph, where it's just like the manager, you just enable it in the manager and exports all the metrics. It works pretty nicely for us, but honestly, we've seen issues that it takes a very long time to pull when you have a lot of OSDs. So we really had to tone it down on some of the larger clusters on how often it scrapes information. But I think there was an issue around that was cleaned up. And also there was another thing that was, if you had multiple Prometheuses scraping at the same time, it held a global lock. So one of them would constantly be timed, like two, if you have three, two will be timing out while one is getting served a request. So that's kind of one of the issues that we ran into when doing that. I know that we had some individuals from China Mobile yesterday. They talked about some of their infrastructure use cases. I'm wondering if they're around and if they do anything that's hyperconverged, or maybe they can share if there's anything on the hyperconverged aspect that they do.
I have a little experience about the hyperconverged systems, but I have some experience to share with you is about that, because now we build the large cloud, so now we use the servers separated. Some are for the computing and some are for storage. For the computing, we use the computing models, and for storage, we use storage models, which is optimized for the different use. For example, the computing and storage. So I think in the large scale scenarios, we will use separated servers for different use. Another scenario is about the edge computing. I think because at the edge computing scenarios, the resources is limited. So we should use the hyperconverged models to both include both computing and storage. So I think at that scenario, it's good to use the hyperconverged models. Another thing is about the operation. As you know, it's maybe it is a pinpoint for the users when the computer is has crash or have some problems, it will have some influence on both the computing and the storage. So how to figure out which is the problem, and it's maybe sometimes it's hard for users to deal with this problem. So I think in this scenario, they tend to use the separated servers for the storage use and the computing use. Another reason is that, as you know, for telecom applications, most of traditionally the application is running on the box devices. So that means the telecom customers is familiar with the pattern that they will use some devices is dedicated for one functions, for example, the computing or the storage. So if the servers involved so many functions, for example, the control, storage, or computing, maybe it's complex for their use. So for our operation team, they like the mode, the separated mode.
Yes, this is Ziqiang from China Mobile. I'm also from China Mobile. We also have our server and hardware team. Yeah, they will define the server for computing, and they will define the server for storage. And the OpenStack team will input the requirement, and then we bought the servers each year with computer mode and storage mode. Yeah, thank you.
I see. That's really interesting. Cool. So it sounds like it's mostly because of the scale. It doesn't make sense to do hyperconverged. So it's very much just different system profiles,
yes.
And you have compute and storage servers.
Yes.
Cool. Well, while we have you here, I guess then we can move on to the next subject, which is kind of dynamic inventory management. And so I think we have some comments already there from someone at China Mobile who wanted to share their tool to does the hardware inspection and the automation procedures when hardware physically arrives. So I don't know if you can maybe unmute and share that a little bit with us to start the subject.
Hello, Mohammed.
Hello.
Yes, my Han will give you some introduction about our automation solutions. Hello, Han.
Cool.
Yeah, hello, everyone. Hello, Mohammed. I'd like share the automation procedure for China Mobile hardware arriving the data center. We have the automation for hardware inspection. First, after hardware placed on racks, we will scan serial number label and get the relationship mapping between devices and cabinet physical position. Second step, we'll do the cabling and automatic configuration for switches, which is the network base for servers automation. Third step in automatic server configuration and check. We have two solutions. Centralized mode and distributed mode. In a distributed mode, first, a dedicated VLAN for PXE boot is prepared in all UR2R switches or management network plane. Auto tool as a PXE server will push a PXE image running in RAM to all the target servers once they become power on or reboot. When agents inside the PS image, when the target server boot up, the agent will be running status, which will communicate to the auto server and upload all the concerned device information to auto. Actually, the large scale servers auto check task is distributed to all the agents running in the different servers. So when servers number increase a lot, auto check consumption time almost doesn't increase. In one resource pool of China Mobile network cloud, there are about 1,500 rack servers. One round of servers auto check takes 1.5 hours. In this mode, besides auto check, auto tool can also auto config IP address and host name of all servers BMC ports and enable all network cards LLDP setting according to the low-level design data, including all server serial number. In centralized mode, auto tool will assign IP address to server BMC port by DHCP. Auto tool in centralized mode will on its own acquire and collect all target servers information through unified Redfish interface, which is defined in the specification. The workload on auto tool is higher compared to that of distributed mode. When server number increase, the auto check consumption time will increase linearly. But the advantage of the centralized mode is the requirement to network is simple and doesn't interfere server's OS. This mode is applicable to small-scale servers to auto check and resource pool carry service expansion scenarios. Okay, that's my content to share. Thank you.
That's very interesting. So I would appreciate if you can also share that on the Etherpad so we can have a log of that information in the notes, because I think that's really interesting to discuss that. So that's really interesting to hear a story kind of from, I guess, introspection and automation at a very high scale, especially in the scale of China Mobile. But I'd like to maybe wonder if John, maybe you can share a little bit about how, I guess, KOB's, inspection and dynamic inventory management works out, just to kind of share the different stories of how it's possible.
Yeah, I can share some stories from KOB land. I think Mark's here as well. He can share some interesting stories as well. This is one particular project that we're sort of currently working on. So it's just over 10 racks of machines, I think, we're trying to onboard all at one time. But yeah, it's a kind of similar approach to similar kind of approach in that there's a handheld scanner that determines like which machines have got in which rack. That gets cross-referenced to the details that we get from the vendor about what they've actually shipped into the data center, so you know that those two things match up. And effectively, KB it's making use of Ironic an Ironic inspector to do various bits and pieces. So one particular mode we're trying is actually we guarantee that these machines came with the out-of-band management doing DHCP, in this case IDRAC. And then what we were able to do is basically you configure the switch so that IDRAC, its packets are going onto a tagged VLAN inside the network. That what we actually did is we actually used dangling neutron ports. I'm not sure whether this is meant to be a feature or not. If you have an unplugged neutron port, Neutron DHCP is quite happy to hand out all of the information, which was convenient. So basically, we're using Neutron to drive the IPAM. So we just had a little Terraform script that takes the CSV and creates neutron ports. So that handed out all the IPs that are now known to the out-of-band management interfaces, and then that was then all enrolled into Ironic. And really what I wanted to do is to make sure that Ironic could do all the state management. So it's already got state management for all the different stages of onboarding as far as I'm concerned. The only extra thing we added was we actually used the extra information in Ironic to just say which bit of the onboarding process we got to, just to make sure that the scripts that were running through could say, oh, I've done X, so I can move on to Y. For this particular case, the tricky thing we had is that these are, I kind of mentioned it a bit yesterday, they shipped with Mellanox NICs that we had to flash and then turn into Ethernet mode in order to be able to do the LLDP on. So you kind of wanted to get the point where you've done the firmware flashing of that. So it turns out, yeah, we could, once you got the system into Ironic, we're able to use out-of-band inspection to discover the MAC address, to then do the neutron port trick again to hand out RAM disk booting. So basically we booted into the inspector RAM disk, but this wasn't actually the inspection network, it's the outbound management network. You could probably just use inspector, but anyway, that meant that you could determine the MAC addresses, the known ones, and do that. But yeah, there's a lot of scripting on that, but it had a lot of the hooks to help through that process. And obviously using inspector rules to try and classify the nodes. So in this nodes, as you know, you've got high mem nodes versus low mem nodes within the cluster. And we can use the inspector rules to just sort of kind of add the appropriate resource class into Ironic as required. So effectively try and feed that inspector JSON file into through the rules to do the right thing.
It's really interesting. So I looked at the repository with the inspector plugins that you have. Those are really neat, and I guess we should probably, it'd probably be nice to upstream those as well.
Yeah, that makes sense. If they're useful to other people, for sure.
I think at least one of them has been upstreamed. Harold Jensis was putting together a similar plugin. So I think we grabbed the kind of the base class from this, and then which one was it? I think it was the system name Fiznet one. Anyway, if there are others that are useful, we can upstream those as well.
Yeah, I know for a fact the InfiniBand one, especially getting the physical network, is one that like we were starting to write. So now that I see this, I'm like, well, this is nice and useful. Should probably work on this together then. Cool. I think those are two kind of ways of like inspecting. That covers a little bit of what and how Ironic also does it when we talk about KOB, because it kind of indirectly uses the same kind of idea or platform. I know Jaden talked a little bit about the hardware challenges that's preventing them from automating system onboarding, more specifically about VLANs to manage networks and BMCs not supporting tag traffic. So, you know, can you maybe expand a little bit on that?
Oh, sure. So since in our environment, we're going to be running multiple separate distinct clouds using the configuration I discussed earlier. So we wanted to be able to isolate those clouds and isolate the hardware management system from those clouds so that a user can't accidentally or intentionally make changes, because we recognize that IPMI has a lot of vulnerabilities historically. It hasn't had a good time. So we wanted to try to do things to secure our network in different ways, but we found that some of our BMCs don't support using VLANs or tag traffic or things like that at the hardware level. So that made it difficult for us to manage the networks in the way that we would like. So we've had to come up with some workarounds, like using ACLs in our switches and controlling like where the traffic can flow, physically segregating different parts of our network. So like only certain specific machines are connected to certain, like we have a separate network or separate physical switches for our IPMI interface to try to isolate further there. And then, like I said too, we just had trouble, like Ironic has good Redfish support, it looks like we haven't any problems with it, but whenever we try to do specific things with some of our servers, you know, what might work on one server doesn't work on the other server. Just because the vendors, maybe they didn't do Redfish all the way yet, or like they prioritize certain pieces over other pieces, or they just have their particular dialect of Redfish, even though it's a standard, it just is different for that particular machine type. But yeah, those are some of the issues that we've had. I would say otherwise, Bifrost and Ironic and the work OpenStack has been doing has been great for us for automating and moving forward with the hardware automation.
That's good and interesting to hear. Has anyone had similar struggles with hardware as some of the ones that were just shared? No, I certainly know that. Yeah, go ahead.
Redfish is definitely one. I think that's partially why we have a whole topic for it in the second half of this morning. So after the break, we'll end up talking about Redfish, and I think we'll get into some of those issues and some of those headaches and pain points, and hopefully find things to fix or work on.
If we want to shift gears, I will say, I forgot to write down, but we did have some trouble with getting the images built well, like disk images or operating system images built in such a way that Ironic can use them. At some of the tools, like I know we had some issues going to CentOS 8, like trying to use a CentOS 8 disk image using like Disk Image Builder or some of the other tools that KOB and Ironic recommends. I think D King, Daniel King, who's here, can speak more to that for me. So I know he's done more of that stuff for us than I have.
I think that at the time, I'm sorry, we were using KOB, and I think I was having more trouble with some of the configurations there, accepting it. But yeah, the disk image builder, I think I've got that mostly worked out. I'm trying to remember if there's anything still outstanding with that one, but I know there have been different quirks with using it at times. But for the most part, I think we're pretty solid.
Just while we're on that topic, I suppose I should say I discovered that Disk Image Builder has breakpoints, and after I discovered that, my life was a lot happier. So you can drop into the cheroot at the right moment when it all breaks. So the breakpoint on error, yeah, it stopped me shaking my fist and having quite so much coffee between runs. So I'd recommend it. Just as a heads up in case anyone else misses that.
Is there a document you can link to in the Etherpad to help everyone else?
Yeah, I'll go find the link.
Thank you.
Yeah, that'd be pretty useful for me. I know that I'm having an issue right now with the disk image builder with one of the IPA images that I can't. The dev user is on there, but it won't let me log in with the dev user. Just keeps erroring out, and I can't debug that yet.
That one's always an annoyance. Yeah. Okay. I always tend to set the password, I don't know, in a dev image and shove out a dev image.
Yeah.
The password setting that's not working.
It sounds like we have a bug we should fix.
Maybe. I always get confused about which key gets injected. I think that's my problem. Because I forget which user ran it with what key, and it's never the one that I have.
That does bring up a point. I'm using the disk image builder to create a raw image, but then later on I'm using Packer later to update it. Now, for my deploy image, I'm not using Cloud in it, so I'm trying to bake the public key in, but I don't have a way of doing that with disk image builder. I know with disk image builder you can create a dev user and you can set a password on there, so that's something. But it would be nice if there was a way to inject. Some generic credentials, maybe even root credentials, because that'd make it easier. Right now, I'm just using guestfs tools to modify that image before I then take it into Packer.
I should link to the docs because there's definitely a whole load of options that let you give the dev user sudo and then let you set keys.
Well, I saw that for the dev user. The problem is that for some reason when I was trying to run Packer with QEMU, it was not for some reason accepting the become with the Ansible provisioner. So it was there's probably more issues than just that. But yeah,
I'll give it. Yeah, I think I've got a link to. We were trying to make an experimental way of running Python inside Disk Image Builder, so you didn't have to do everything with shell scripts. Or rather, you can share the Python, the Ansible that you're doing post deploy with the run the Ansible inside the Disk Image Builder pipeline. Let me try to look up the link for that. That might avoid you having to use Packer.
And we have a comment also shared that sometimes if SC Linux is around, it causes issues connecting as dev user. So maybe that's related, or an insightful comment that might be helpful. And kind of going back to briefly touching on this is, what about automating offboarding? You know, it's probably not something that's very common, but, you know, is there anything you do in that scope, or is it just delete, get rid of the disks, just ship them off to a company that does destruction and move on with life?
Well, I think for the most part, that's true for us. However, we typically have a bunch of back-end systems that have to be pulled out. So we've automated a lot of the removal from the back-end systems, but the removal of the images from the box, yeah, you're right. We don't pay a whole lot of attention to it, which we probably should, because they have, you know, customer keys on them and other sensitive data.
Yeah, that's true. Obviously, that needs to be stripped off.
Yeah, I know one organization that's at least contributed a bunch of logic to help support tearing down machines and retiring machines was CERN, actually. So what they do is they actually, hopefully someone from CERN can take over here with this, but my understanding is they set a retired flag, and when the machine's deleted, it goes through the entire cleaning process, and then at that point it doesn't get rescheduled, it can't be rescheduled, and they can just basically unenroll the machine at that point, and it's ready to go repurpose, or, you know, I don't know, sell on eBay to recover some of the expense of the original machine. I don't know what they're actually doing at that point, but
yeah, but that won't impact the images since they're in the repository. They're not on the machine itself.
I'm a little confused because
that sounds about right, Julia, from what I understand. In fact, the machines at the end are often given to collaborating labs in countries around the world, like Lithuania and Morocco. So we do things like reset the IPMI credentials as well to be really sure that we're not leaking anything.
And the reset or the retire flag was mostly added in order to like ease the handover between the different teams. So like the ironic team managing the physical nodes and the team that's actually preparing machines for donation, to like ease the handover, we introduced this retirement flag that could be set at any moment. And then the moment the instance gets deleted, the retirement flag actually allows the machine to still be clean. So like as Tim said, like erase the credentials, erase the disk, do another burn-in, because we usually like test that the machines are like, they go through the same burn-in basically and the same testing as we get them initially. So before we donate them, we make sure that they're absolutely working fine. And this is why we had this retirement, because Ironic didn't have that mechanism to actually allow cleaning after you mark the node for being retired. So this is what this retirement flag is for.
That's really interesting.
That's very interesting. So if we have a command to kind of restore the node to the initial or pristine state, would that be helpful? Or it doesn't really matter?
Well, this is basically what cleaning is supposed to do, right?
Yeah, but cleaning does not return it to the original state. Cleaning will remove some of the stuff, but doesn't mean it will return the configuration to initial state, including
I think,
RAID and stuff, other stuff like that. It will do some cleaning, but it will not return to the
yeah, I think our
pristine
case thoughts
state.
is like the machine is not going to come with like root Calvin username password and like the OEM shipped defaults.
No, but the like initial state is like the disks are completely erased. There's nothing on the disks, right? And the like BMC credentials are reset to some random things. So this is what cleaning is supposed to do.
So I think that there's an important delineation that needs to be made. With Ironic, you have hardware managers, and these hardware managers can be dynamic. And sites like CERN do have additional hardware managers that they use. So you're able to actually, depending on what the hardware actually boots up and sees, take additional actions or additional processes. So they could actually, their hardware manager could actually see, oh, I'm retiring. I need to do a bunch of extra work now.
right? This is actually what we do. Like, for instance, for the RAID configuration, what we do is like, rather than making this manual cleaning step, we added this to our downstream hardware manager. So the moment you clean a node, it actually checks the RAID configuration that is configured and resets the RAID configuration to that specific state. But this is all like, you have to have, as Julia said, you have to have your own hardware manager where you like instructed what to do.
It's a really interesting conversation on this subject, and we got like 7 minutes before our break. We kind of have one more topic, and I feel like this last topic is one of those kind of really interesting in theory. I don't know if anyone is doing it yet, so we'll get a chance to kind of all sit and imagine what would be an ideal world to do this. And so this is one of those ideas of changing bare metal machine roles kind of on the fly, and the ability of maybe having one machine that's being used as bare metal, and then if you need extra virtual machine capacity, you provision that as a hypervisor and connect it to OpenStack and use it as such. And then if you need more bare metal capacity, you unprovision those machines and provision them back as bare metal. So kind of like a back and forth system that allows you to have a pool of hardware that could be either computes or bare metal machines. And I know Julia seemed excited to see me bring this up. I want to hear thoughts about that.
Well, my dream would be that we build our data center such that when we don't need a bunch of spare capacity running, that we start shutting down or idling or even somehow suspending the physical machines, so that we reduce that power capacity, reduce the cooling usage, maybe even make the noise level a little quieter, because, you know, as someone that has some hearing damage, I don't want more going into a data center.
Yeah.
So to me, it's like the ideal thing. And I would love to have some requirements or understand what people feel they need in these kinds of situations, because I think we should be building these applications to be dynamic and elastic and also treat our underlying infrastructure. So the question for me becomes, how do I, or what requirements do I need to meet in like bringing that machine back online as it was, or provisioning the same thing again, or be able to shift machines' roles? What orchestrations needed? How would we approach this? Because you don't really think about these sorts of things often when you're running tens of thousands of machines, but even 1% of your power bill can be a huge savings, a huge amount of savings on wear and tear on equipment.
Yeah.
I mean, then again, you may also increase the cost, the wear and tear on the CPU fans or whatever, but these are the kind of things we need to think about in our society and our environment at this point. I'm sorry, I'm rambling.
Yeah, I think that's really interesting.
This is Rob Hirschfeld. I can talk about what we've built from a pooling capacity and the use cases that we saw from that perspective. Pooling is a delivered feature for us next week. It's a tricky feature.
Is it my internet or is it Rob's internet?
I think it's Rob's internet. Oh.
Yeah, I think it's Rob's internet.
Yeah, Rob, you're cutting in and out.
All right, hold on. I'm gonna have to leave and come back.
Okay, I think I heard, or Katie maybe wanted to comment on something.
No, I was just curious. Do we really have decent data in terms of, you know, bringing power things up and down multiple times? What is the actual wear on the hardware? Is those kind of scenarios? Because most of the time people kind of turn it on and it's running all the time. Yeah, you can reconfigure it once in a while, but you know, powering it up and down is a very different set of the you know, wear and tear on the node.
That's absolutely true, and I've moved data centers and feared what would happen to the physical disks. Would they actually start spinning back up at all?
I will show my age and talk about the old quantum disks that would, if you ran them for a long time and you stopped them, the lubrication for the bearings would freeze, and you had to whack them on their side to get them going again.
That's awesome.
Wow.
On that note, at least now these days, SSDs, I don't know if anyone has any of the Intel one, like 2 terabyte SSDs that had the lovely firmware bug of spontaneously combusting after like 1800 hours of runtime. Like they literally just die, and there's a firmware update for that. So yeah, guess who learned about that? I did. So that's one of the interesting ones. I see Rob is back. Maybe want to hear some of the.
Yeah, can you hear me better now?
Yeah.
Much.
Oh, sorry about that. When I move around, it jumps hotspot or jumps Wi-Fi zones. Yeah, so this is a delivered feature for us in the upcoming release, and it's tricky. And the use cases you're describing, one of the challenges of doing that is the reliability of the backend system. Oh boy, I'm trying to think of the right place to start because I want to be use case focused in the description. So the use case you're describing seems pretty straightforward from a resource pool. It gets tricky quickly because then you start getting things like we talked about yesterday, where is there zones or machine specific information that has to be considered in the allocation request, because it falls apart if you're asking for a machine or for a specific machine. It requires you to say, I need a machine from this resource pool, usually matching this criteria. But then the thing that makes it this untractable for a lot of use cases that I've seen is that if it's not incredibly reliable, then people won't trust it to do the nightly migration. So it's the dropout rate is just as much of a problem. And so one of the things that when we built the feature, we were incredibly careful with was transparency in the operation. So for us, because of the workflow integrations for Rebar, what basically is happening is you're getting a machine, you're getting and it starts a workflow for you. Those two operations together are the requirement. Is not as simple as just giving me a machine. It's giving me a machine and start this workflow. And then that translated into parameters and profiles that you have to set, because you then have to influence a whole bunch of information pushed through that process. And then if something doesn't work correctly, you have to have a state machine behind the scenes that's going to decide to hold, wait until the system's done provisioning. When it is done provisioning, hand off to other links. So the state machine behind this actually got pretty tricky from that perspective.
Yeah,
it's the thing that's nice is that at the end of the day on that lets you drive like Terraform. So you can take Terraform and create a provider, or say a cluster API and do a provider. Those systems tend to require this. The other use case that we see for this is not dynamically shifting workloads, but being able to actually use other cloud-based tools for hardware. Ends up being pretty straightforward on the APIs, right?
That's interesting because it sounds like a lot of things you've experienced needing. It sounds like most of it we already have, at least in the OpenStack community. We're probably just missing some of those edge interactions and requirements, but we're also kind of over time.
My expectation for the OpenStack community is that those use cases will be fulfilled by using Ironic under OpenStack as letting OpenStack be the API provisioner. And so from that perspective, you have a resource pooling utility built in. Not built in is the problem. But there's a lot of overhead from that perspective to make it let go.
Okay, that's really interesting. So I want us to put a small pause on this discussion, because actually I think this topic leads on really well for the topic that we're going to be discussing after the break, which is talking about preemptible instances, which really is also another way of reusing bare metal. And it's a similar use case. So I think we're going to be going on break until, and we're going to come back in 7 minutes, if I'm correct.
You are correct. Yes.
Perfect.
We'll see everybody at 14:40. So yeah, in about 7 minutes. So enjoy your quick break and we'll see y'all in a bit. All right, hello everyone. We are back and we are going to keep rolling into bare metal infrastructure part 2. We'll be talking about things like preemptible bare metal and circling back on Redfish, which I know was mentioned earlier. Great conversation, so let's keep it going. And I'll hand it off to Julia.
Thank you. I guess I kind of want to take a quick step back to where we were talking right before the break, which was auto-scaled bare metal for cloud workloads. And we had a great conversation. We had to kind of cut it a little short because we need to take our break. But I've added a list on the Etherpad, and I just want to say if anyone's interested in continuing discussing the topic, that we have a place where we can add names and we can circle back and try and see if we can create some common workloads or common use patterns or common tooling and make the world a better place. And if there's anything else anyone wants to say about that section, now might be a good time.
I guess on my side, I really did enjoy that discussion, and it's something that I feel like is interesting for us because we do have the same exact pattern and the same exact quote unquote flavor of hardware for everything. So it would make sense for us to be able to shut down machines. I don't know people working in other data centers, but once you hit a certain scale, even if you have cages inside data centers, you get charged based on power draw. So there's a big difference of having, you know, on a Sunday evening where everything is not really getting loaded and you have a bunch of empty hypervisors. So you can shut things down versus, you know, on a busy Monday morning. It's a huge difference.
Or maybe even some way of idling the machine or orchestrating, hey, turn down your processor capacity way down and maybe deprioritize, or who knows?
Yeah. So another really interesting thing, and James Pennick is not here, but he talked about this idea, and I will take zero, like this isn't my idea, it's his, because I think it's really smart. I'm not gonna take any of the credit. But they were looking at actually using the idle workloads, the idle machines as serverless systems. So anytime you need to run any serverless workloads, they go on these idle machines because they're not doing anything. And you kind of have this infinitely kind of scalable idle machine pool resources for serverless workloads. And you know, that's probably a good way of using that hardware. I found that really interesting. But you know,
likewise. And someone also pointed out that it would be interesting if they could just automatically replace one of the nodes in the workload if it failed or had a problem. And that seems like kind of the other end of that use case, but it seems like something equally as important. Anyway, our next topic is preemptible bare metal. use cases for turning unused bare metal into cloud infrastructure, orchestration, and thus ultimately security around doing such things. So I'm wondering, to start off, has anyone considered or explored preemptible instances?
Yes, we've definitely had a look at preemptibles. I've been involved in some of the work trying to get preemptible support into Nova with CERN. Yeah, and CERN, I mean, maybe CERN should talk about aardvark, the aardvark approach. Is that Arnie writing that?
I think so.
Right. So yeah, so we've been working on like a tool called Aardvark that's meant to deploy preemptible instances, but this is mostly for virtual machines. It's in a state now. So basically the way it happens is like you can tag certain projects and mark all instances that are in there can be basically removed in case there's like a request with a higher demand from a different projects. So you can basically fill your cloud and you have like a fraction of them are instances that run in these preemptible projects. And the moment another VM comes along, the request is basically put on hold. Then Aardvark comes along, kills some of the instances, makes space for you, and you can launch, and the deployment of your VM continues. We haven't tried this with bare metal instances yet, but it's definitely something that we want to look at, because what happens, at least what we observe, is that usually you buy a lot of physical nodes and then they're there, but it takes sometimes days or weeks or even months until they're like running the use case that they were intended for. And during that time, at the moment, they're basically shut off, sitting there and waiting for the end user to basically instantiate them and like bring them into their service. So if we could use preemptible instances for this, like you could have something that where you just create an instance that is like pulling off some work from a work queue and chew on this in the days and weeks and months until the final user comes along and say like, hey, I'm now ready to instantiate my service. But the user doesn't need to tell us, just tries to create the corresponding instance, and Aardvark comes along and cleans up the preemptible instances and then launches the instance. So this is, from what I understand, we haven't tried this, as I said, with bare metal instances. We have this in certain cells at the moment with virtual machines, and it seems to be working fine. So we basically now fill all the cells, like 100%. And then when users create an instance, preemptible instances are killed, the request is put on hold and then continue to be deployed if there's enough space when the callback comes in. But for bare metal instances, that is something that is on our radar to do as well.
I guess the next question from that would be, is there anything that you need or want in order to help facilitate doing something like that? And ultimately, I think the question is open to everyone on this call.
I suppose the biggest blocker, maybe this is an obvious statement for the preemptible workload, is just the amount of turnaround time for the deploy time. That becomes way more critical.
Yeah, I was just thinking exactly this. Also for like the previous point that we had, I didn't mention this, but like the time to deploy a virtual machine compared to the time to like clean and deploy a physical machine is still significantly different. And there's other things that go into this. We have talked about like the resource tracking, for instance. So this is OpenStack specific, but like the time it takes to the system to realize that a physical node is free is macroscopic. And if you say like you want to have instances, bare metal instances that are during the daytime doing this and during nighttime doing this, you lose quite some time to move them from one to the other, which would be much shorter with virtual machines. But like with the Ironic, okay, this Ironic specific again, but with the IPI and the integration with Nova, in principle, it should work with bare metal instances just as it works with virtual machines. Probably the failure rate, because it's hardware, is higher. I would expect, at least from my experience, that like creating instances is
oh, do you mean, yeah, the create instance failure rate?
Yes, create instance failure rate is higher, at least in my experience, to like things that Rob was alluding to earlier, or Jaden was saying, like there's different machines, they all behave differently, things change, so that's a little bit different. But I think all the building blocks are there. So I'm really eager to try this out, especially now that we have like Aardvark running with virtual machines in various cells already.
Yeah, we have done some work with trying to get like Slurm batch services. So, you know, the batch queue system in Slurm can basically decide I need more space and request the cloud for more space. I guess it's no surprise saying you can use exactly, if you get it working with OpenStack VMs, which we have, then you can do the same thing to get it working with bare metal instances. We tested that out, and it works fine, but the turnaround time basically meant we went back to VMs for doing development.
What we usually have is like we have what we call opportunistic batch. So they're like specific projects that automatically create instances, and they try and try and try. And if there's space, they succeed. And then like once the instance launches, it pulls off work from the queue and just starts working on this. And then, but then they can be killed in case some other, but this is a full manual process. And now with Aardvark, this becomes automatic.
So we have a great question, Etherpad, and it's not bare metal specific, but would single tenant virtual machine usage be a compromise point?
Yeah, so that's my question. And like, so what I mean by that is, could you just deploy one VM that has all of the resources of the bare metal node allocated to it, and that's the only VM on that hardware node, and you use that to try to make it preemptible? I know it's not truly a preemptible bare metal use case, though.
We've actually been typically, for the workloads that are more dynamic, we've often gone for 2 VMs, one on each NUMA node, to try and get, that seemed to be a better balance of the system, but I think it's a good question. It depends exactly on the workload, as you say, like how bad the hit is.
Well, one of the difficulties that I see here, this is also like something that was mentioned earlier, where you turn a empty or free bare metal node into a hypervisor, is like, that's pretty complicated to do. It's not just like you flip it over and then it's a hypervisor. You have to at least, okay, maybe that's like our deployment specific, but you have to do a lot of things. You have to add it to a cell. You have to like register with placement. It has to be discovered. It has to be added to all kinds of databases. All of this can be automated, but at least in our case, it's not fully automated A to Z. So there's still quite some steps that need to be done before a physical node can become a hypervisor.
And
that's a good point.
We're going back to the, yeah, I was going to say, maybe we're going back to the previous topic, but we've definitely been doing that to some extent. So in sort of a simplest case scenario, you can actually, if the machine is empty, which is a big if, you can move it in the KOB inventory from being a hypervisor to a bare metal node, and then work around the bits and pieces. Because in KOB, you've kind of got the whole machine, the switch configuration, which ones are hypervisors and bare metal compute nodes all in one repository. So it's quite easy to see that in the diff. It's not perfect, but yeah, we've been trying to work on the tooling around that to make that easier.
You can also play some tricks. So one of the tricks that we're playing, for instance, when we need to reinstall a hypervisor. So our hypervisors are also bare metal instances. One of the things that we do when we reinstall them is like it keeps the same everything. So basically, we don't like deregister it from placement or from Nova or whatever. It just keeps the same everything. And so what you could do in theory is basically have the hypervisor registered everywhere, and then basically like move it apart without telling anyone, using it for someone else, and then putting it back. That would like shortcut many of the things, but it's, yeah. Well,
I feel less bad about my plan for that though. Because I was thinking exactly down the same lines, as it's basically registered in both places and it's disabled some of the time, as in it doesn't exist right now. But
exactly.
Boo-hoo.
Yep.
That's definitely an interesting idea. And if you didn't have to necessarily scrub the disks, or you could reduce the pre-provision time dramatically, then it could almost become feasible at that point.
You're saying you don't want to scrub the disks between which transition?
If you could, flipping in between workload usage, or if
I mean, yeah.
I mean, if there was I need to dedicate, this hypervisors I've used, I've moved all the work VMs off. I just want to turn into a folding at home machine overnight or something like that. There could definitely be tooling to kind of help enable some of that.
I think you could save on having to scrub the disks if you use network mounted storage for the virtual machine. I know it's not quite as good because you don't get the high performance of the local disk, but it would save you from having to scrub the local disk.
Right. If you're using SSDs, you can just change the key. The disk
I was going to say, yeah, if you've got secure arrays, yeah. If you've got secure arrays, it's nowhere near as bad. Which, ironic.
The other option would be if you were really rotating this quickly. This is Rob. If you're really rotating this quickly, you could set up 2 partitions if it was a known thing, and then you could mount one partition for one and one partition for the other, and then you'd be able to swap the machines back and actually keep a high degree of persistence from that perspective. We do something where we just use our in-memory OS, and then we'll mount the disk, and so you can get very consistent behavior. It's not as friendly because you're now constraining people more. But.
What I was just kind of thinking about is if we could offer the ability to, I need to boot into this RAM disk. So everything I'm doing is basically ephemeral, and I may not be touching the disk, and it might be a known thing. And if I'm the same tenant, maybe it's okay. I'm just running a different workload for a little while. And I could actually see that same usage and pattern becoming very powerful for people who need to do like maintenance, or I have super special hardware, I need to run this super special update. And the only way I can really do that is to reinstall an OS or a specific thing to be able to do that.
I like that idea of running a RAM disk. Yeah.
So we did do that with Ironic, although it'd be nice to make it a feature in Ironic more properly. So what we did was the dangling port in Neutron that I spoke about before. You can add all of the options to tell it to do the right IPXC, and then use Ironic to power it on. Now that's definitely cheating, but it did do the correct RAM disk boot. But it'd be nice if it was a thing we could request. That's a good point.
I'm kind of wondering if there needs to be an ephemeral, please do this thing temporarily, and we go ahead and actually reconfigure, at least on Ironic's case, reconfigure what we have on record and kind of swap in a new active profile and be able to swap it back and forth. Here's a temporary thing, go do this.
I guess it's surprisingly close to rescue, isn't it? It's just not rescue.
It is.
It's an interesting case because I don't think I'd thought very long about the special case of if there's only n workloads, then if most of them are RAM disk only, you really do make life easier.
And I really like the idea of suspending, like kind of disabling the compute node. I mean that, and just recreating it or reprovisioning it or going back to that OS. That seems.
It does work. Yeah, it does work quite well. The only problem is upgrade. Unfortunately, the auto pinning logic can be a little bit annoyed by the fact that the old hypervisor exists, because you can go into compatibility mode. But if we ignore that, then it's okay.
I mean, and if someone's just, say, donating their compute cycles because to, say, folding at home or computing decimals of pi or trying to break RC564, then it's a thing that they can run in batches during non-peak load, and just they can come back to it later, or as long as they have those mechanisms to be able to go, I need to kind of start shutting down and save my work. Which is kind of takes us back to the preemptible uses and interactions.
I think highlights the use of the profile. So you can quickly switch from one profile to another.
And I'm not even sure it's necessarily a full reconfiguration that would be useful from at least most operators, because if wiping the disks may not be a thing, and it might be that there's some legitimate use cases for being able to go, I need a temporary OS in this, it's different. Here's how to do it.
There's a lot of use cases for that.
As kind of pointed out, it's very similar to Rescue.
I know you're describing what we consider sort of default workflows, where you bounce through an ephemeral OS as part of a workflow control system. Yeah, it's super handy. We use it amazingly a lot.
Now, I guess we did kind of briefly talk about some of the security concerns that might exist with doing such things such as this. Does anyone have specific concerns or worries, or would everyone be thinking something like this would be single tenant, or like the operator of the infrastructure doing it?
Do you mean if a machine switched ownership, that it would be a multi-tenant environment, so the tenanting of that machine could change between who had control of the machine while it was reallocated?
I'm not necessarily thinking of changing tenants. I'm more thinking what would be the security requirements if there were, I guess if we were to support multi-tenancy transactions there, it might be interesting. But I think ultimately, if we're changing tenants, the machine probably always needs to be wiped. I mean, if we could snapshot quickly capture data off the machine and then play it back onto the machine as efficiently as possible, that's probably a whole nother case that could be really rapidly reprovisioned. Just depends on what's already there and how much data has to be moved.
Yeah, it's a data movement. It's not that hard to capture a machine and store it from an ephemeral boot state. Copy the drive and create a copy. That's pretty standard process. And then restoring it's pretty straightforward too. But it can be huge amounts of data to do it, and that can create wire problems. And just the compression time, if you're doing real compression. It's okay for a day's reassignment.
What do you mean a day's reassignment?
So if you were trying to do it, the analysis that we've done and when we've done prototyping on this, for example, the use case that we get is before I do an upgrade, I want to make a backup of a system. So you boot into an ephemeral disk, you copy the system off, then you reset the machine. Or, if it's not good, you can reset it back by dropping the disks back in. Just pretty straightforward type stuff. The challenge is that the time it takes to do that, if you're actually going to compress the drive in a reasonable way, if it's a big drive, can be out, over an hour. And in that case, then you don't want to do that for a couple hours of use in the evening, just to secure the system. In a multi-tenant environment, if you're just flipping the system over, right? You can k-exec into a new OS and not even go through a reboot cycle. But so for what I meant from a day's perspective is if I was going to give a machine out for 3 or 4 days, making a full backup of it, utility-wise is reasonable. Conceivably, you could save a lot of time and transfer by storing it on the same disk system. This is the use cases that we've explored. You would actually save the backup on a disk in the same array on the same system, so you don't have to transfer it off. You're just copying it over to another system, and then you could sign it and encrypt it and make it available. Somebody could still delete it. Just depends on how much you trust your operators, your guests in the system.
Yeah, at least in the the fully physical world of a decade ago or so, I was doing some similar things in data centers where we would image the running machine and save a copy of it locally to support various fast restoration processes, because playing back a 700 gig database from tape was just a nightmare. And it was pretty bad just going from that to copy on disk.
Right. But the use cases that we see for image-based deploy are typically from CI pipelines where you build one image, you can invest in compressing it so the wire transfer is not that bad, and then you clone that. The idea of doing the individual disk cloning, people like to talk about it. It's just the overhead on it has seemed high. The tech isn't hard. Actually, all the tech is there. It's where are you going to store those images? How much time it takes to get them done? Type of thing. It's an interesting use case from that perspective.
Has anyone looked at using Blazor for things like reservations in a sort of use case like this?
So I can talk about Blazor. So the Chameleon cloud is using Blazor and has been for several years now. I think it's been running for 5 years. Using Blazor upstream, you can do that with virtual machines. No changes required. However, it relies on host aggregates, which don't play very well with ironic nodes, because Nova host aggregates are based around the Nova services themselves rather than the compute node. And so in Chameleon, I was working on Chameleon in the past. We opted to incorporate some changes that were made by JPipes to change the way the aggregates are managed. But this wasn't approved upstream, and the alternative is to use the placement aggregates. And so this is something that we'd like to get in upstream Blazor, but that's not been done yet, mostly due to the lack of access to a good development environment for this. So it's something that we're hoping to make progress on this summer, as we're working on getting. I think Stig mentioned it in the last OpenDev, on working with Vern to get like a community platform up and running. So yeah, short answer is it can be done, but it needs a bit of work compared to the code that's available upstream.
Now, when you say a bit of work, do you mean just for VMs or for VMs in bare metal, or bare metal only?
For bare metal specifically.
Interesting. Is anyone else using Blazor in this case, or this sounds like an interesting opportunity for collaboration?
Yeah, I'm not aware. Yeah, go ahead, John.
Oh, sorry, I was just going to say I do work with Pierre, but we've been working with some other customers as well on looking at Blazor, and I think Pierre's been prototyping some work on preemptibles. Pierre, have we got a link to that Coral Reef Cloud presentation that we did together? There's a UKRI in London presentation we did about the plans around this.
Yeah, I don't think we have a public link, but I can share the slides. I'll put them in the Etherpad.
Yeah, I keep meaning to do a blog post on this. We should do. So one of the thing, a very common. So I'm going back a little bit, but one of the main things that's causing me to think more about moving from bare metal to hypervisors is we're working with quite a lot of clouds where there's a scientific clouds where there's a resource allocation committee saying that there's this mix that needs to be in this quarter, which is a different mix to the next quarter potentially. So it's actually often it's only quarter on quarter changing what the mix is. And that kind of says what kind of balance you want to have in resources between different scientific communities. Like, you know, these get so much, this other person gets so much. Now there's a whole load of, if you try and do that naively, right, you want to use quotas. So you can kind of say, you know, you get so much, you get so much. But that very often the allocation that you have is more temporal. So it's kind of like the amount of time you can have a flavor times, you know, the length it's running. So it's more like a billing restriction rather than a actively running restriction. And generally these clouds are quite high levels of contention because everyone's kind of wanted to do, you know, everyone wants to run more simulations to get their error bars down. So there's always work to do. So effectively, Blazar is kind of an interesting way that you can kind of visualize who's using your cloud when, and then fight with other people to get the reservation slots. So you can sort of fight into the future about who gets what when. And effectively, most people, but there's a lot of people doing this in spreadsheets right now. It's just Blazar lets you do that in a more sort of API-driven way to say, you know, I get it this week, but, you know, Bob over there gets it the next week, you know, whichever, and share it between different people. Anyway, so if you do this reservation carving up, one of the problems you can get is that you get gaps in your schedule. So we really like to fill those gaps with preemptibles, because you've got jobs. If you've got a job system that can sort of proactively create VMs, in fact, actually, the system that we're currently testing this prototype with is exactly the same system Arne, I think, was talking about. Some of the grid PP workloads, they're quite good at spinning up VMs and trying to run relatively short running jobs inside them. So there's ideas of trying to balance the demand profile using that. But really this is about APIs describing what's already being currently done manually, if you see what I mean.
Kind of.
I gobbled that quite a lot.
So I guess kind of the point of this discussion at this point is that preemptibles are not for the faint of heart. Blazar is also not for the faint of heart. It's more for the full deployment experts that know exactly what they're doing and have that time or those cycles to actually do that kind of resource planning and allocation. As you said, a resource planning committee.
Yeah, I think it's where you've already got external constraints, and this is kind of like so maybe it boils down to actually, I think, a bit of that original conversation we were talking about functions as a service. In order for preemptibles to work, you actually have to have workloads that can make use of preemptibles, and in a way that you can get the machine back again. Because in these clouds where you've got, in the private clouds, you know, you tend to have fixed capacity, and what you're trying to do is get maximum value, in some sense of value, whether it's scientific output or whatever, with it from that fixed capacity. Part of it being that stuff that can run elsewhere could run elsewhere when you're full, for example, right? So you kind of try and get the best fit of resources to where it's running. I guess what I'm trying to say, you need to have the correct back pressures in order for preemptibles to work. And it's not, at the moment, they're all, the facilities that we have in OpenStack are kind of in development. So I guess the people that are in the positions where this is interesting to, please reach out and collaborate with the folks that are muddling through at the moment. More of us showing what we're doing, or get a more general solution, I guess.
So it seems like we should add another item to Etherpad where for people to add their names if they're interested in collaborating in this area and on solutions related to preemptibles and handling ephemeral workloads or workloads that need to be able to come up and go away on fairly rapid succession.
Yeah, I think that'd be good.
Is it linked to the stateless versus stateful thing, or there is, as you're running it in a preemptible way, you have, tooling to, I don't know, store the state outside of the cloud or in some form or shape?
Maybe there's two lists. Maybe there's a resource management list and a stateless workload and ironic list.
Seems reasonable.
Yeah, I couldn't work out how to write down what you were saying earlier, Julia, but I think that's a good split.
Well, hopefully people are interested in both.
The evil monkey on my shoulder says it so. Oh, that's another good use case for using the flavor size where the local disk GB is 0, which no one should be using anyway.
I thought that wasn't even saved or used anymore.
No, it's disabled by default now.
Oh, good. Whew.
Or disabled for admins only by default, maybe.
Okay. Well, our next topic is managing your hardware using open standards such as Redfish, which is a dramatic shift from our prior topic. And I kind of want to start the discussion off with a specific question of, are you using Redfish right now? And if we want to, I think it would be good to kind of jump into a discussion of discussing the overall state and perceptions and even pain points if so desired. So we could probably, do we need to do like a quick little informal poll in Etherpad, +1s for Redfish, +1s for still using IPMI, motivation for why?
And both.
What was that? Oh, and both. Ooh.
Yeah, our experiences, there's no uniform. So it's actually IPMI, Redfish, and vendor.
Sorry, you broke up there for one moment.
Sorry. Our experience is IPMI, Redfish, and vendor. So it's actually the truly heterogeneous what we see. I'm just trying to capture the options for both.
So, Rob, are you seeing machines where IPMI no longer works properly, so you're using Redfish?
We're seeing machines that start in IPMI and then transition to Redfish, pretty common, or ones that start in vendor and have to transition to Redfish. Redfish is becoming very popular from what we see, but it's not uniform, and then systems sometimes have to switch back or start in the wrong state, so we can't. It's hard to make assumptions. Like if you switch to UEFI, then that might force Redfish. But if you have to switch back to legacy, then you might not do that. Right?
I think I guess John made a kind of interesting question, which relates to something that we've started seeing some signs of out there, is some of the ways that you have available to say, I want to boot in UEFI mode that are generally cross-vendor compatible via IPMI. The underlying mechanisms are actually being phased out by organizations like Intel. So we're going to start seeing like the ability to say, I need to set these raw flags into the BMC, just disappear. And that's going to make it very painful for people to continue to use IPMI, especially if they want to say, I want to boot my UFI workload on these IPMI machines. And some vendors have done customized device lists, but everyone seems to approach like UFI a little differently. And how, like, I know one vendor, you don't even really have an option. It's boot devices as opposed to a general operating mode of the machine. Also, go ahead.
Oh, sorry. It wasn't that interesting. What I was going to say is I've started to see some boxes shipping with IPMI turned off now by default. So Redfish being so preferred, the IPMI is actually turned off.
I've started seeing that. I've also started seeing security improvements and changes with like the IPMI command line tool, such that we're starting to see cases where things start breaking with BMC firmware updates, like request retries, or cryptography is one of the more recent ones. So one of the highlight items that a couple of people have brought up is the fact that things are kind of inconsistent. And I think it kind of lends itself to the way Redfish is being approached and the way Redfish exists as a standard. Because when we probably all think standards, we all think there's a specifications document, and the specifications document is fairly specific on what you shall have and is optional. And I think a lot of the issues people are running into right now are largely because the specification is much more about the root endpoint and the basic version data responded, and the methods and mechanisms at a higher level, not the actual data points and basically the switches and knobs available via the API. And when you're automating bare metal, it's obviously something where you need those switches and knobs to be consistent or to have the same basic mechanisms across vendors to really support automation. So I'm wondering if anyone has specific pain points that they're encountering, or if they have items that they're curious about, or things that they need or are finding frustrating with it or not.
I mean, something I've had, like I would say, issues with is while Redfish is a nice standard, the implementations vary from one vendor to another. So like in theory, like for example, I had a case, and I think I shared that with you, where it was a specific vendor where the NIC devices would all appear and they would return with the correct MAC addresses when doing inspection using Redfish, but they would all return that their value is down, which meant that Ironic would just ignore them all because they were all like disabled or downed. And there was like no why this was happening. And so that was like a little bit of a struggle in order to be able to get that going. And it's kind of like a big, box that we don't really know it's happening and going in and out, and it's hard to always assume consistency in the Redfish API, other than certain operations that are like the fundamentals. But beyond those, it's very much a wild card of support levels of the API.
Yeah, but there's an interesting thing that we've seen in this is that since the API varies rev to rev, and the implementation sometimes vary rev to rev even within the same vendor chain, it can be problematic not just across vendor implementations, but even vendor implementations within a series of time.
I've seen cases where across a series of time, vendors have changed names of fields. I've seen vendors indicate that their version is one version, and they're leaking in fields and information from later versions of the standard. I've seen the complete reverse of that in different vendors. So I think a lot of it comes down to how people are interpreting the standard when they're actually implementing the DMC features. And I know we as a community probably need to have a cohesive, strong voice and go back to the vendors and try and go, here are our pain points, and here are the things that we need. And there is some work going on to try and at least create some standard profiles so that we can at least say there's compatibility with these vendors, or these vendors have certified compatibility through these profiles.
Yeah. We raised this with some Redfish people, so we have the same experience. And there is a certification effort underway, very nascent, to basically be able to test Redfish compatibility to spec. And having that would be useful. Then you could at least confirm everything you described, like things changing names and stuff like that. We've seen also. It's worth noting as a shout out for the Redfish team. This isn't a beat up on the Redfish team.
Oh, yeah, no, it's not. It's definitely, there's a disconnect in between the vendors trying to continue compatibility for things that they've supplied and keep things simple for their users and translate that forward, and also stay compliant with the standard, because the standards, as the DMTF chairs have actually said on a recent Ironical, the standard's a moving target.
Is this something that so we've got an interesting opportunity here? If there's like several open source projects all using Redfish, is it worth agreeing what those projects all agree to be like a very useful minimum bar?
I think there is some ability for that, and I think that I know the DMTF would be receptive to that and be willing to accept a profile of like the minimum bar or minimum basic requirements for interoperability or behavior. And I kind of, to take a quick step back, I'm wondering if the compatibility testing, was that that Rob mentioned, I think, is that the DMTF compliance testing, or is that the actual certification profile work that they're doing?
I believe it's compliance testing. I'm trying to see, let me look through my notes and see if I can find what that is.
Yeah, I think part of this, where this also gets difficult, is how open that standard is. It's going to end up being, oh, you have a boot object. Awesome, good for you. Not necessarily what's in the boot object.
Yeah. Yeah, it's a hard. I'm looking. Sorry, I'm looking up what.
Oh, no worries.
If I can find it, I'll post it.
Are there, I mean, beyond kind of the weirdness that Mohammed mentioned, was there any other weirdness people are encountering? Sort of things that we could probably work around in software to recognize, oh, that's probably not a big deal, or there's another approach that we need to take?
I think there is a hidden requirement that there is expectation that you have written it for one type of the hardware and you will be able to port it and run it on the other type of the hardware because it's a standard. And I think this is kind of the requirement which we indirectly state. And then when we try to, demonstrate it, that we are bumping into the problem. Partially for, because standard is pretty, pretty young, so there is no, people have not done the full implementation in many cases, or because the interpretation, as you pointed out, or the product releases, change things a little bit, which causes a change in the behavior.
Indeed. I kind of also suspect what we'd still run into is the state matters, and I suspect like the out-of-band inspection indicating that the ports or ignoring ports because they look down is probably just because the power's not on for the machine, and so line carrier isn't officially online. So there's probably some slightly different interpretation of how that data gets reported across vendors. I bet another vendor would probably say, well, power's off, but I have line carrier, so I'm good.
Yeah, I mean, in Dell, for example, you can power on iDRAC where the rest of the server is down, so you can configure it the way you want it to. But obviously, the rest of the node will not be functional yet. So, again, it's interpretation of the standard.
Indeed.
Oh, sorry, need to drop.
Yeah. No, Julia's asking a great question, though. It's what is the feedback for this? I don't know. We struggled with this on the team also because we're influencing the spec wasn't as exciting to us as dealing with machines that show up, and having to fix whatever arrives from a vendor perspective. The best defense I could see is having a way to do a test of any system as part of a qualification run. So when we onboard equipment, we'll put it through a pretty exhaustive validation series and test check. Writing something like that for the Redfish spec is going to be hard. There's just a lot of vendor wrinkles.
Yeah, and we even today, we still run into issues where a new firmware version comes out and all of a sudden things are just slightly different. Mm-hmm. And that causes unexpected behavior. Like one vendor had made a change to one of the field handling because of a comment that was made in the DMTF document that wasn't saying remove this. It was just basically implying we never intended for this to be the case. So everyone went and ripped out the support. It's like, no, that's not what you're supposed to do on a stable API.
Yeah.
So, yeah. With the number of people still using IPMI, I kind of feel we should probably take a step back and also get an idea of the essential things people are using in IPMI. That way we make sure we have those bases covered, at least as open source projects, for when IPMI starts really becoming broken or vendors say, nope, no more IPMI, so that we can maintain continuity for the users.
Yeah, it'd be really good if, maybe this is exactly what you're saying, if we get the Redfish support unified enough to the same level as IPMI when IPMI goes away, when that's the case, I guess.
So I just added a couple of things to Etherpad around line 260. Boot device, whether it's network disk, power on or off, non-masking interrupt. Ah, yes, indicator lights. I guess I should fix up that hatch for ironic so that we have it for IPMI as well.
Boot device is boot order from that perspective. We find
I guess
super important, which includes network boot.
Yeah, I guess some of the vendor extensions do allow you to assert order for IPMI.
Yeah, we have a pretty common use case for people that want to be able to come in and say, we're done network boot, switch to disk boot. And then when they realize they need it back, so we need to switch it back.
Yep. we tend to take the I want to do overrides approach, but that's even somewhat problematic on Redfish, because that whole approach starts changing when you go to UFI, and in the schema 1.10 standard, it starts changing again. So.
I was just going to say, I've noticed that when we're doing the overrides, sometimes that's now actually requiring a boot cycle to apply the override, which I'd not seen before. I don't know if other people were seeing that.
I would be really concerned about that. Is it doing it itself, or is... Okay, so
it's you submit a BIOS settings change, and all BIOS settings change now appear to make a boot cycle on some hardware.
Via IPMI?
This wasn't IPMI, sorry.
Okay.
This is using the vendor one.
I think that's also the case in Redfish, because I know
okay, really?
For supporting, with some vendors supporting virtual media, you end up in a case where you actually have to make the attachment and assert the configuration to boot from that device as separate jobs.
Okay.
So people have added graphical console on IPMI. I wonder who's actually like issuing IPMI command line and somehow getting a graphical console, because I currently need to order some of this hardware.
It's probably the like built-in web server that has access to the console.
I know what I was thinking, but it's important to ask.
Yeah, and Supermicro makes a separate like standalone software that interfaces with their BMCs using IPMI or Redfish. That provides like a local graphical interface. As another example.
And I can issue some commands since I've downloaded the Java files. I can issue a few commands and then pop up with the graphical console through the Java applet.
So it looks like we have a fairly complete list. Server sites.
Everything.
Yeah.
No, you don't get to choose. I mean, the thing that's not on this list is really like BIOS configuration, rate configuration, things like that. This is more the utility of, except for the temperature readings piece, is the utility of power on and core ops, which is what the question was, right?
Yeah. Well, basically, how are you using IPMI today in terms of like the IPMI protocol and the related actions that may be supported to make changes to the machine? Because it seems that we should probably endeavor to ensure that we have these same basic things moving forward.
But the temperature readings thing sticks out to me because that's a polling data, it's a sort of time series type of information. Is that I'd be interested to see how much people are looking for time series out of band system information as part of a core requirement.
So I and my cohorts worked on some of this work recently, and we see some interest and a lot of interest more along the lines of being able to do alarming for the chassis and collect the data. The conundrum, I think, is when you say, give me all the sensor data on IPMI, you end up with getting a giant blob of data that you have to parse through and return data. With things like Redfish, you end up having to gets against multiple endpoints to kind of hunt down that data. So I think there's dramatic differences in how that data collection needs to perform. And I think like threshold settings, I think that's more up to monitoring systems, especially also like fan speeds, power supplies, input voltages. So our approach on Ironic was at least just present it out to like an exporter or kick it to the message bus via sensor data and just let the operator make those decisions?
We've often come back to that's a monitoring thing, not a control thing. That's why I was asking from that perspective.
It's a great question. Now, go ahead.
Go ahead. No, that's fine.
I just noticed someone added serial ID, like serial number, I guess, which is an interesting item to use across IPMI, but it would be fairly unique considering most BMCs are unique to the motherboards at this point.
Yeah, we use the I think it's a serial ID, but from that snapshot I took, those things in the brackets, those are all the serial IDs for the servers.
Awesome. That was the screenshot of the rack level green or red indicators.
Yeah, exactly.
That was really cool.
Thank you. We can also query, by the way, in those, we have a sensor section, and we can get the temperature, voltage, current as well in all from that. So we don't typically do it, but in some cases we have. Like last year, one of the cooling systems went down, and they're like, turn everything off, turn everything off. And so we could watch, and we powered down a few racks, and so from the talks yesterday, I think I'll actually incorporate the temperature settings into the output of this as well, so I can see a 3D temperature of our setup. And we poll every 5 minutes.
Are you just asking the BMC for the SCR data?
Yeah, I think so.
Yeah, that means you probably already have in that blob of data you're getting back.
Yeah, we get it, and we parse through it all.
We did very similar thing with the Prometheus export for Ironic.
Yeah. So yeah, when we query something like the temperature, it just spits back 35 degrees or whatever it's going to be. So
awesome. A few more comments on the Etherpad regarding mixing both IPMI and Redfish. I guess it's much more of a topic that I was ever thinking people were using.
Hello, can you hear me?
Yes, we can hear you. Go ahead.
Hi, this is Jin from China Mobile. I just want to share our experience using both the IPMI and BMC simultaneously. Actually, we just missed the usage of IPMI and Redfish for the server configuration and the check. Like for the server BMC configuration, we use a PSC procedure to load the image to each server. And then our agent in the image will finish the related BMC configuration, like the IP address, gateway, or mask through the inbound BMC driver. And after the BMC got the IP addresses, and then we'll use our automation tool will use the Redfish interface through the out-of-bound network. Yeah, we just use the Redfish interfaces to retrieve some server-specific information, including the MAC address, the hardware component related info. Yeah, this is just our use case. Yeah.
Interesting. I had a thought, and now it's kind of run away with me, and I'm looking at the time and wondering if anyone has anything else to add, because I think we're actually about 15 minutes from wrapping up. Yes, I have a 10-minute-ish warning a few minutes ago, so.
I had one related topic, if it's interesting to people, which is the no out-of-band management at all case, like Raspberry Pis.
Those are fun cases. I know some people are working on enhancing support for such things, at least in Ironic. I guess people, go ahead.
No, we did actually a bit of work with Pis, because you can get them to Pixie boot pretty reliably, but you do lose out of band. Some people are building some out of band consoles or serial console boards for them. I don't think they're following Redfish or even IPMI, but I was curious for the group if it's something like a Pi with no out of band management, or a NUC, which only has what's that spec? The Intel PC.
Oh. Yeah, the one we had a driver for a long time ago. I can't think of what it's called.
It'll come back to me after the call, I'm sure. I was just curious. We don't have to drive into it, but it's starting with out of band management is something we've spent some time on. And
Yeah.
it's useful. I mean, the Pis are fun, crazy, cheap little machines.
Oh yeah.
64. So.
If you happen to have links to these BMC boards people are developing, I think that'd be actually pretty interesting for at least people that are doing development or want to play around with stuff, because if we can extend support to make it easy to do stuff like that, then it spreads the ability to adopt and ability to develop.
Yeah, they're all sort of random. We talked about this. I do a weekly DevOps Lunch and Learn, actually today. When we talk Central, and we had somebody, Federico, actually, who's friendly, and y'all probably know, talked about Pis and some of them. We talked about the boards towards the end of it. I'll throw a link.
Awesome, thank you.
Maybe a semi-related thing. I'm wondering if people are wanting to try and integrate the smart PDUs. I know there's I think it was a smart PDU driver to do the power control and then do everything else. But I'm more thinking when you're using the smart, more just to sort of tag them in Ironic. I mean, my current plan is I'm thinking of possibly populating the chassis. Not that we use chassis much, but to try and model that. And it's more just for the monitoring, just so it's easier to get all that information through the Ironic API to link where the power is to the machines.
There has been some discussion of both supporting smart PDUs and vendor native power interfaces. And I think a lot of people want that more for monitoring, but also if the BMC is broken, you really don't want to have to dispatch someone in a data center 500 miles away to go push a button, because there's a minimum half-hour service fee charge at an insane amount of money.
It's sort of, I think I've heard it also particularly with the switches. Like sometimes you kind of just want to hard reboot the switch that's in a HA pair for the same reasoning. But it'd be interesting if you could model that. I suppose you probably can already model that in Ironic a bit.
At present, really only one or the other, but the chassis, that is interesting. And that could be really powerful, actually.
In the particular case I'm thinking about are these machines where we've got 4 machines in 2U, where they've actually only got 2 power connectors coming out of them. which is a lot of people are using those just for the density. But yeah, it's interesting when you try and do energy, because the board tells you what it thinks it's doing, but the PDUs tell you what the whole chassis is doing across the 2 ports.
Yeah, that makes a lot of sense to at least be able to have some way to correlate it and then track it back, because you have to monitor it. It's not just the PDUs, but you have to monitor, or not the inter-chassis, but you have to monitor the PDUs. You have to make sure that you are accounting for the breaker degradation over the lifetime of the breaker. I know it's what I'm referring to as a really obscure thing, but like breakers lose like 40% of their capacity over 10 years or something ridiculous, which is why residential breakers, you'll find if you have loads that often peak up pretty high, that suddenly the breakers will start popping without actually you having done anything other than like maybe turn on your oven.
My parents had that with their shower, I guess, but yeah, same difference.
I actually had this happen in a giant PDU in a data center once. I was the crazy person that just said, fine, I'm gonna change the breaker right now. It was also a production outage because it could no longer take the load of the rack.
I didn't know they degraded over time. That's interesting.
Yeah. Interestingly enough, I think like American Express has some insane number of patents because they identified it as their major failure point in their data center. And they developed a lab to actually study breakers and improve breaker design. Amazing what comes out of data centers sometimes. Well, I believe it's, go ahead.
I was going to say we are just about at the end of the time for today. I wanted to give Mohammed and you a chance to share and summarize any of the highlights that that y'all appreciated from today's discussion.
Yeah, I can start about this. Yeah, I think we had a really interesting conversation that started with an awesome question that was left by Julia, which is like, hey, how do we define what is hyperconverged, which is a line 65. And we had an interesting discussion on how there's probably some similarities in hyperconverged and edge computing, and there were some parallels to be drawn. And we had some really cool feedback from a couple of different users that were kind of running OpenStack in different ways that they were doing hyperconverged setups. We also talked a little bit about running Ceph and doing hyperconverged Ceph, or kind of when you're running monitors and OSDs all at the same time. So, and also about the maintenance, upgrade, and all the other things that come along doing that. We also had some really interesting sharings from the team at China Mobile with regards to their tooling that does all the scanning and everything, and which is really interesting how they have two systems that works either in a centralized or distributed mode, which brought some interesting feedback. And then John also shared a little bit about how Bifrost or KOB uses Bifrost and the ironic inspector flow entirely together. And then we talked about some challenges on why you're not actually automating your system enrollment. And so that was one of the things that brought up some discussions around disk image builder, some discussions around VLANs, and maybe some just older hardware that's just not that easy to work with. And then at the end, I think we wrapped up on an interesting idea of being able to switch workloads from one different profile to another. So you can have a machine that used to be a hypervisor that becomes a that's a hypervisor that becomes a bare metal machine, and vice versa. So those are some really interesting topics that we had discussed today. And what's interesting is there's a few people that listed their emails who are interested in discussing some of those use cases. And so, yeah, it would be good to put in your email in there if that's something that interests you as well.
Agreed. And
I somewhere around line 205, I guess it is that the.
That's fine.
Yeah, let me.
242, I guess, is maybe the. Yeah, there are a couple of spots.
Yes, and there's 209 and but 242, I'll leave that for Julia to discuss.
So we really got some good energy, I think, going when we started talking about the autoscaling bare metal cloud workload infrastructures. And it was interesting to kind of not only hear the use case of kind of being able to move things around and changing, but then also the replacement machine that's failed in at least heterogeneous environments. Then we also kind of took that same energy and went into talking about preemptible workloads and trying to somehow utilize your bare metal infrastructure for other things. And largely kind of the big concern or blocker that people have to doing things like this seems to be the time to turn machines around. So it seems like we kind of reached some conclusions of things that could be done or that not necessarily could be done, but that would be good starting points for these things to be able to be automated or to be usable, and some of the other use cases that could be leveraged around these things. Which we did end up having getting to the point where we're starting to discuss both from the resource management standpoint and from like the stateless workload standpoint, or more being able to support ephemeral workloads. So we have two separate lists of email addresses for people that are interested to kind of keep the discussion going, starting at line 243 and then again at line 249. And then we started talking about Redfish, which it was really surprising for me to see the number of people still using IPMI, but it also seems like we're all kind of having some of the same pain points.
Supports my theory that in the technology industry, we never get rid of anything. We only add new things.
It sounds right. And for me, yeah, for at least my standpoint, finding out what people are kind of presently using it for is really powerful, because that gives us an idea of the bar we need to hit or the things that we need to consider or make sure that we have support for in order to make everyone's life better, so they don't have to go drive into a data center. And also hearing from people trying to use both at the same time, that seems interesting to me, but I guess it kind of makes sense if there's not parity between the two, or more parity work is needed. And then, well, I was gonna say, then we got talking about some interesting variations on machine management. And I really do want to see if I can make Raspberry Pis do things now.
Cool. Well, thank you for both for moderating and leading the discussion today, and keeping it moving along. This, I think, has been one of our most active OpenDev discussions yet. Tons and tons of notes in the Etherpad too. So that's awesome to see all of that. So Ashley, why don't you wrap it up for us and remind us about tomorrow?
Yeah, that was awesome, everyone. Yeah, so tomorrow, make sure to come back, same time, same place, and we will continue our discussion on networking. And then we'll also do the wrap up tomorrow. So just as a reminder, we do have an Etherpad for tomorrow already set up, and the moderators, Mark Goddard and Ian Joliffe, have already added some content to that. So we're going to drop that in the chat right now. So make sure to go ahead and check that out and add any comments in there, anything you want to touch on relevant to the discussion, so that they kind of know how to direct the conversation tomorrow. And we will see everyone tomorrow.
Yeah. Thanks, everyone.
Thanks.
Thanks, everyone.
Thank you very much.
Bye-bye.
Bye.
See you. Bye.
Bye.